In this nugget, we get to lab up and verify EIGRP authentication. Let's begin. One of the challenges we often face is that if we're running a routing protocol and we're sharing information, how do we know we're sharing it with the right people? One method of helping to verify that we're talking with other routers that we manage is by setting up authentication. And it consists in EIGRP of creating a keychain and then going to interface configuration and telling it that we want to use MD5 for EIGRP authentication and specifying the keychain to use for that authentication. The commands we'll use in this nugget are in the Nugget Lab files as well as the topology diagram, which consists of R1 and R2, which we'll implement in GNS3 and will enable EIGRP along with authentication between the two of them. For more information on EIGRP authentication, please visit Jeremy's route course and his nugget that focuses on EIGRP authentication. In GNS3, let's build our topology with all the wonderful two routers that we need for this. We'll grab R1 and R2. We'll use the connector tool to connect them together using their gig 1/0 interfaces on each side. We'll also put on the label tool just to verify that we have the right interfaces. We'll turn off the connector tool. We'll start the topology, and then we'll click on the icon to get console access to each of these routers. We'll begin our journey of configuration right here on R1. We'll go into configuration mode, and we'll create interface loopback 0. And we'll give it the IP address of 1.1.1.1 with a 32-bit mask. And we're going to advertise that in EIGRP just to validate that EIGRP, once it's all set up, is working correctly. Next, we'll go to the gigabit 1/0 interface here on R1. And in interface configuration mode, we'll give it the IP address of 10.12.0.1 with a 24-bit mask. And we'll bring it up with a no shutdown command. Next, let's enable EIGRP for autonomous system number 7. We'll put a network statement in for 10, another network statement in for 1. That'll encompass our two interfaces, and we'll do a no auto-summary. If you're on iOS 15 like I am, you won't need that. It's off by default. But if you're labbing this up on iOS 12.x, which is perfectly fine, I want to make sure you have similar results as you're seeing us do right here together in this nugget. Our next step is to create a keychain using the syntax key, chain, and then the name of your keychain. In our case, we're going to call it our-chain. We're going to create a key for key number 1. So we're going to say key space 1. And now we have the option to implement our key string. So for our demonstration, let's use key-string, and we'll use capital N, UGGET, exclamation mark, 23. And then we'll exit all the way back out to global configuration mode. Next, we need to tell interface gig 1/0 that we're going to use MD5 authentication for EIGRP for Autonomous System 7, and we're going to tell it specifically what keychain we're going to use as part of that authentication. So to do that, the syntax in interface config is IP authentication mode EIGRP, our AS number of 7 MD5, and then followed by IP authentication key-chain EIGRP, our autonomous system number 7, and then the name of our keychain, which is our-chain. And that's it. R1 is ready to rumble. The problem is R2 isn't configured yet, so let's make a road trip over to R2 and we'll configure R2. So here on R2, we'll go into configuration mode. We'll go into interface gig 1/0. We'll give it the IP address of 10.12.0.2 with a 24-bit mask, and we'll bring it up with the command no shutdown. We're also going to enable EIGRP here on R2. So we'll create the routing process for EIGRP Autonomous 7, and we'll add network 2, which covers our loopback, and network 10, which covers our gig interface. And we'll use the no auto summary in case you're following along with iOS version 12.x. Now, just for grins, let's go back over to R1 just for a moment. And here on R1, let's do a show IP EIGRP neighbor just to verify we don't have any neighborships. And sure enough, the neighbor list is empty. Next, let's do a debug of EIGRP packets, and that will help give us an insight as to what is potentially going wrong. And right there it's showing us we have the problem. So let me go ahead and turn debug off. We'll do that with a undebug all. And you'll notice we have the statement of missing authentication. So it's seeing these hello messages from R2, but because the authentication isn't there, it's ignoring those packets. So let's correct that. Going back over to router number 2. And here on R2, let's create the keychain. We'll call it our-chain. That's the name of our keychain. We'll use key number 1, and the key string we'll use is nugget exclamation mark 23. And it'd be pretty important to have the same string on both routers if we want the authentication to work. Now, you'll notice we do not have an EIGRP neighborship yet because we haven't yet told the interface on R2 gig 1/0 that it should use MD5 authentication and also which keychain to use. So we'll correct that by going into interface gig 1/0 and say IP authentication mode EIGRP7 MD5 and IP authentication key-chain EIGRP7 and the name of our keychain, which is our-chain. And with that in place, if it's working correctly, we should get a neighborship between R1 and R2. And there it is. That's fantastic. And we could verify that we've learned some routes from R1 by using the command show IP route EIGRP, and we should see the loopback address of R1, which we do, of 1.1.1.1. And we should be able to ping 1.1.1.1 as well, which we can, and that's great news. In this nugget, you and I have labbed up a simple EIGRP topology, and we've added the authentication factor for EIGRP. I appreciate you joining me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.